in our last class of the Getting Your Garden Started series. It's been a pleasure to have you all with us on Friday mornings. We are going to today discuss the soil lab results, soil test lab results that you all got back, and have a deeper discussion about soil nutrients and amendments. And then we're going to talk about compost and getting a compost system set up if that's something y'all are interested in. Bethany has put the soil lab test results for those that have them back in a folder in our week 5 Google Drive. So if you took a test and you haven't seen your results yet, check that folder. Your name should be on there. And we can stick the link back in the chat so you can access it quickly or easily. If you have, let me see. What do we need for class today, Bethany?
We need our soil sample results. I'm going to put this in the chat real quick. Okay. And for folks who had emailed me and said that maybe not all of their samples were back, a whole bunch came in last night / this morning. So I put a whole bunch in around 8:30 this morning. So if you checked previously and maybe yours weren't there, or only half of your soil sample results came back, please check again this morning. And the link to that folder specifically is now in our chat for everyone. We also need our calculating soil amendments worksheet. Let me grab our handy list so make sure I'm telling you everything. So you need to grab your soil samples results pages, your calculating soil samples results worksheet. If you have crayons or markers or colored pens or pencils, I find it really helpful for kind of circling different things in different colors, because that's how my brain organizes things. If that's not how you work, that's fine too, but it may be helpful to have at least a writing utensil and then also a calculator on hand. We're going to do a little more math today, but we'll walk you through it. And we are always here to answer questions for folks afterwards too, if you need help. So I think that is it. And are we ready to dive into being soil scientists?
Yeah, let's do it.
All right. All right. So last week we talked about soil texture and how soil texture is kind of one piece of the soil ecosystem that we're thinking about for our plants, right? Texture really focuses a lot on our drainage availability in our soils. So how well our soils move through and retain water. And that also relates to what we're going to talk about with our soil sample results, which is how well nutrients stay or move through our soil, right? Because a lot of our nutrients can be moved with water. So this is just, right, our soil texture was one piece, and then together with our soil nutrients, we're really going to kind of dial in on what kind of food and environment our plants are living in. So you all got a soil sample result back. If you just did a soil nutrient test, this is what you got. If you did a soil lead test, you got a sheet back from the University of Massachusetts that also has soil nutrients listed on it. But it also does list lead levels as well. And we're going to talk about that specifically a little later. So if you want to start by grabbing your soil sample results. So what this test does is this test is telling us what food is available in our soil at the time we took the sample. So that means plants can't get up and go get their own food. They have to rely on what's in the ground in order to make all the food that they need and to get all the nutrients they need. We take soil sample results to figure out what's there and what, if anything, we need to add to our soil to give our plants the food that they need in order to grow and be healthy. This is why when we're thinking about soil samples, we don't want to do anything, any amendments or add anything to our soil until we have taken our soil sample results. If you take your soil sample results and then you put in a bunch of fertilizer and a whole bunch of compost, the results you will get back afterwards are not valid because you've already changed the nutrient composition of your soil. And that also, right, our nutrient composition of our soil also changes from year to year. Every time we plant something in the ground, those plants are extracting nutrients. Some plants are putting nutrients back into the ground, but those levels are always changing. So at a very minimum, if you're doing intensive gardening, you really want to think about doing a soil sample either at the end of your planned growing season or before you grow in the spring. So kind of that November to January, February timeline is really the best time of year to take a soil sample for your garden. So we all got this sheet. It looks kind of scary. There's lots of numbers on it, but we're going to talk about what's going on and what to do about it. So the first thing, if you've got a yellow pen or pencil or just a pen, if you want to find the soil pH on there and draw an arrow to it or circle it or highlight it, just so you know what it is. So let everyone kind of do that. The soil pH on this sample is 7.7. And I want to ask if anyone has heard of the terms pH before and if they can kind of tell us what that might mean. All right, so soil pH generally tells us how acidic or basic our soil is. So an acid, right, we know what an acid is. It's something very astringent. It can burn. Something that's very basic or alkaline, we tend to associate with cleaning products like soaps, but they can also be caustic at extremes. So our pH scale is logarithmic from 0 to 14. With 7 being in the very middle and being kind of a neutral. So water, it has a pH of 7. It's neither acidic nor basic. And then everything kind of moves out from there in both directions. If you are growing a diversified garden, which we hope everyone is doing, we really want to aim for a soil pH of between 6.2 and 6.8, which is just slightly acidic. And that's what's optimal for a diversified garden. If you are planning on doing some perennial crops, like asparagus or blueberries, or if you are someone who is maybe thinking about commercial growing and doing like a large field of only tomatoes or only potatoes or a specific crop, that is a time where you would want to kind of dial your soil pH down to that specific crop. However, if you're looking at a diversity of different plants that are annuals that are growing every year, the 6.2 to 6.8 pH is really what you're hoping for on that front. So just kind of, so now that we know that, we're going to kind of go back and check out our soil sample results. So on this sample that we're looking at here, our soil pH is 7.7, which is very basic. So this is a situation where we would want to start thinking about acidifying our soil to get it down to that 6.3 to 6.8 range. What are folks seeing on their soil sample results? Are they in terms of pH? Does anyone want to share? All right, so while we are checking out our soil pH, so we can kind of think about pH in our soil as kind of like the overall environment that is present in our soil, kind of like the air temperature. outside for us as we're walking around above ground. So for soil pH, we're looking at this chart because the pH, that kind of environment in the soil, kind of how acidic or how basic it is, impacts the types of fungi and bacteria that can live in the soil. It also impacts the availability of different nutrients that are in our soil. So you'll notice that the soil sample results list lots of different things that our plants need. Just like we take a multivitamin to get some trace minerals, plants also take up a lot of different minerals to help them grow. So if we're looking at this chart, if you'll notice that the horizontal bars represent, the width of them represents the availability of different things in the soil. So if our soil pH is between 6 is around 6.5, what do you notice about the different bars of these different plants, of these different minerals? Sorry.
They're wide.
They're wide, right? So that width is representing, and that 6.5 is the optimal level of availability for those different nutrients in a diversified garden. So the soil sample result that we just looked at is at a pH of 7.7. So let's look all the way to the space between 7.5 and 8 on our pH scale. And what do you notice about the widths of the bands at that extreme?
Well, some of them are narrower and some of them are wider.
Right, exactly. So as we get to an extreme in pH, all of a sudden calcium, which our plants need only a little bit of, is very, very available in the soil. But something like iron and manganese and zinc is not available as much at that level. The pH of the soil inhibits, when it gets very basic, inhibits the availability of those certain nutrients. Right, and then the same if we go to the other extreme. So if we have a very acidic soil around a 4.5 to 5, what do we notice on the other extreme? So that other extreme, right, the same thing happens. All of a sudden we have a lot of aluminum that is readily available in the soil, iron, but pretty much no calcium, no molybdenum, very little bits of copper, and a whole lot of zinc. So again, right, once we hit these extremes on either end, that throws off kind of the nutrient availability for our different plants. So that's where we start to see nutrient deficiencies in plants. Is sometimes it's not because the nutrient isn't present, but the pH of the soil is causing a nutrient deficiency. Does anyone have any thoughts or questions about that?
So for example, if it's very acidic, no matter how much nitrogen we put on the soil, that's not going to help it.
Correct. Yeah. So that's one of those things, right? So if you have a soil that is very extreme, just because you're pumping in a whole lot of extra nitrogen, right, that promotes green leafy growth, your plant can still have nutrient deficiencies because it can't get the calcium it needs, for example. So it's right. It's a kind of a bigger picture of, wow, what's happening underground. That's a good example, Karen. I like that. So when we're looking for our, looking at our soil pH, this is a different sample. And this soil has a pH of 6.7. So that's kind of moving into that optimal range. So in this case, the soil does not need any kind of soil additive to it. If we look at kind of this bottom section, if you find the purple square that says lime, has anyone ever heard of someone or know someone, or maybe it's you, that just adds lime to their garden every year?
Yeah, I do.
Okay. Why?
I don't know exactly why. It makes the soil better. I think it makes it more acidic.
So, right, so the lime actually makes our soil more basic. It increases the pH. which might be appropriate for your garden. And this is why a soil sample is really important. Because in some situations, your soil is very acidic and it may need lime to be added to it to make it more basic, to get it to that optimal level. However, not all soils need lime every year. And when we get into a habit of adding something every year just for the sake of adding it, we can shift our soils and our soil pH in a way that may not be healthy for other nutrients. So just really want to bring that to everyone's attention and to please read your soil recommendations, particularly around lime, and follow the recommendations. So if your recommendation is to add lime, we'll talk about how to calculate that a little later on. To add it, if it says none, like this one, you don't need to do it. And you're good to go.
And I hope that that resonates, that kind of message resonates a little bit too with just like fertilizers in general as we go through this talk. Bethany and my goal is to help you all understand how you can know what your soils need in terms of nutrients so that you can avoid adding something every year when your soils might not need it, because you can get to that point like Karen brought up where if you have a pH that is very, very acidic and you just keep adding nitrogen, the plants aren't even being able to pick it up. You can also, if you have an optimal pH and you keep adding something in a level that it can become a toxic level for your plants, you can add too much. So this is, just think about this not just applied to lime, but also to kind of all of the other fertilizers that you can add to your soils in general.
Absolutely. Thank you for sharing that too. So again, right, really paying attention to your soil pH and just like Lilia said, adding things as you need and not what you don't. So the next part of our soil test, and this is where we kind of really dig into our soil science, is on our soil nutrients. So we have taken this test to find out what nutrients exist in our soil currently and at what level. And this is to help us make that decision about, do I need to add fertilizers or other kind of inputs to our soil or not? What are the levels that already exist? So the primary nutrients for our plants when we're thinking about food are nitrogen, which is the chemical symbol of N, phosphorus, chemical symbol P, and potassium, chemical symbol K. If you've purchased fertilizer before, you've probably seen these letters and some numbers mixed together on some fertilizer bags, and we'll talk about those and what to do with them as we go. But they are always listed in anything that you're talking about in the orders N, P, and K. And this is kind of, we think about, these are the big three, but nitrogen is the one we always need the most of, which it's kind of like, if we're reading left to right, it's the first one. So nitrogen promotes vegetative growth. It's our what makes our plants green. It's the key ingredient in chlorophyll, and it helps with plant cell formation. So without nitrogen, we don't have leafy green plants. We don't have plant growth, right? This is where it's really important. And this is also the fertilizer that's most commonly used and overused, right? Your plant's not doing well, you give it a little nitrogen, and you get lots of green leafy growth. But just like Lily's was talking about, you can get into an extreme where your plant is only getting the food to grow leaves, but it's not getting the food it needs to grow maybe the fruit or the flower that we're really hoping for. So nitrogen, highly, highly important, but everything in balance. So with that, we go to phosphorus. Phosphorus is key in root growth. So very, very important, but something, right? We don't see the results of phosphorus as much because a lot of it's happening underground. It promotes photosynthesis and also helps increase the structural integrity of the plant. So we talked about last week how 80 to 90% of all of our plants are water. So phosphorus that is absorbed into the water helps hold our plants up physically. So it's doing some very crucial things with the water in there. Phosphorus also promotes flower and fruit formation. very, very important because we see sometimes plants that grow a whole bunch of great green leaves but never produce a flower. And that can be a part of an issue too. Potassium, the final nutrient in the big three, is kind of the silent workhorse. There are no external results of what potassium is doing for our plants, so it very often gets overlooked. Potassium is kind of the key driver in a lot of different enzymatic reactions inside the plants. So it's helping the plants do a lot of different things on the cellular level, from growing food to moving nutrients in and out of cell walls. It's just this little tiny person, you know, kind of moving things around. It's a salt, it's absorbed in water, and it helps increase efficiency in water use. So when potassium is present in optimal levels in our soil, our plants can be more effective in using and transporting water throughout the system. So we don't see any big, like, showy things like a flower or a green leaf from potassium, but it's very important. Secondary nutrients that show up in our plants, these are kind of the two bigger ones that we'll hear talk about associated with plant diseases, but there are many other secondary nutrients that plants need in teeny tiny amounts. So the first is calcium. Calcium helps with cell wall structural integrity. And then also just the overall structure of the plant. So plants that have good sources of calcium are resilient, they're strong, they'll come back if they get bumped. Magnesium is something we need in small amounts, and it's another little teeny tiny workhorse. It helps produce chlorophyll, and it also is a key part of the photosynthetic reaction, right? So it helps plants make their own food. When we go back to our soil sample, you'll notice on the top section of there's this whole panel list that has the nutrient, the lab result, levels of adequacy, and calculated data.
Hey, Bethany.
Yeah.
Is there a way to zoom in on this slide to make it a little bit larger?
That is a good question.
I might be able to edit it on my
Yeah, let me,
screen real quick.
do you want to, yeah.
Here, let's see if I can do this.
Cool, thanks.
Oh, but I'm gonna mess with your squares.
Oh, it's okay. Let's see if we can move them.
Okay.
Ha-ha! Perfect. Maybe. All right, so has everyone found this box that Lilius has made much bigger for all of us?
Can you all see that?
A little better?
Okay, I'll keep working on that, Bethany.
Okay. Yeah. So we've got all these different nutrients and results, but at the very bottom, there's a bar across that says recommendations, and then it has nitrogen, phosphorus, and potassium. If you've got some crayons or colored pencils around, if you want to circle them, I like to circle them green for nitrogen, red for phosphorus because it promotes fruits and flowers, and then blue for potassium because it is associated with water. That's how I help. That's what helps me remember them. Maybe it'll help you, maybe it won't. And so you'll notice with these recommendations, right, if you found them, they all have some numbers associated with them. Is everyone doing okay? Let's see if I can make this bigger. So if you'll look at these, we'll notice that we have different kind of numbers associated with those. Can someone read what the nitrogen says for this sample?
2 to 3 pounds per 1,000 square feet.
Perfect. Per 1,000 square feet. What about the phosphorus?
3 to 5 pounds.
Perfect. And then our potash.
1 to 2 pounds.
So you notice, right? So nitrogen is just nitrogen. The phosphorus recommendation is phosphate. Phosphate just happens to be the material that phosphorus exists in that is most readily available to our plants. So very frequently, right, it's not going to say phosphorus, it'll say phosphate. And then same with the potash. That's where potassium lives happily in a form that can be readily taken up by our plants. So has everyone found these on their soil sample? Once you've got that, we are going to take these and we are going to calculate what these kind of recommendations mean for our specific garden. When Karen read this, you'll notice it said per 1,000 square feet. So for example, for the nitrogen, that would mean I would need to add 2 pounds of nitrogen for every, if I had a 1,000 square foot garden. I do not have a 1,000 square foot garden. So we're gonna work together on our soil sample calculations page to figure out what those results are gonna mean for us and our garden, which may be more or less than 1,000 square feet. So I'm gonna stop sharing here and then go to a different page here real quick. All right. So if you have the availability to pull out the Calculating Soil Amendment Needs handout, we'll zoom this in a little bit more. All right. So the first thing we need to do is figure out how big our specific garden is, and then measure it. So when Lilius and I did these soil sample results, we did them for a raised bed, and the raised bed was 8 feet long. Sorry, go ahead.
Oh, that's okay. I was gonna say 4 by 8. And I didn't know if there was anybody who knows the size of their garden that would want to use their garden as example, because the one that we took of this 4 by 8 bed only had that nitrogen recommendation. Is there anybody that knows the size of your garden and has your lab test back that wants to work through your calculation with the class, and we could just use your garden sample? If not, we can go ahead and use ours. Yeah. Going once, going twice. Okay, well, we can continue with ours.
All right, thanks for checking in with that.
Sure.
So this is also, if you haven't measured your garden yet, this is a good time to go out and do that. One important thing is if you have maybe 3 raised beds and you took the soil when you sent in your soil samples, you knew that they all had the same soil, you treat them all the same, and you did 1 soil sample for all 3 raised beds, then you would do the total area for those 3 beds together to figure out your amounts. Does that make sense? So if I had 3 4 by 8 raised beds, it would actually be 12 by 24 if I were going to do it that way. But since we've only got the 1 raised bed, we're going to use this size. So what I'm going to do now that I've got my length and my width is I'm going to calculate my square feet. So I have 8 feet long by 4 feet wide, which is 32 square feet. So little math for us. Are we all feeling good? All right, so my next question is 32 bigger or smaller than 1,000?
Smaller.
It's smaller, which means that that ratio on my soil recommendations result of per 1,000 square feet is not appropriate for my little 32 square foot garden bed. So I'm going to have to create kind of an amendment calculation ratio. Sounds scary, but what that is I'm taking my 32 square feet and then I'm going to divide it by 1,000. And this is going to help me reduce that 2 to 3 pounds of each amendment down to something that's much smaller, right? So I know about how much of each of those things that I need to add to my soil. And you will do this for your specific garden. So if your garden is more than 32 square feet, you will enter that number and then divide it by 1,000. And then same if it is more than 1,000 square feet, you're gonna divide it. So 32.
0.032.
0.032. All right, so this little tiny decimal number I'm going to utilize later on. But for now, we're going to go back and we're just going to remind ourselves of what our recommended amounts of nitrogen, phosphorus, and potassium are. So looking at the sample that we were viewing earlier, we're going to pick the larger number. So the recommended amount of nitrogen was
3, I think.
3. All right. So we're going to use that larger number for our calculations. And then what about the phosphorus?
I think it was 2, wasn't it?
2. And then potassium.
Actually, I think if we're looking at the one that had the pH of 6.7,
Yeah.
that one was 3 to 5 pounds of phosphate.
Ooh, 5. All right.
I know you all probably can't see that because it's not in front of you, so I'm going back to the screen.
Thank you.
Sure.
And then I think potassium was 2.
Yeah, 1 to 2 pounds. Yeah.
1 to 2. Okay. Right. So that's pounds per 1,000 square feet, but we only have 32 square feet of garden. So now I'm going to figure out how many pounds of each of these things I would need individually for my garden. So I'm going to come down here to number 5. I need, the recommendation is 3 pounds of nitrogen per 1,000 square feet, but I'm going to use my little amendment calculation ratio here. So 0.032. And I'm going to multiply 3 by 0.032.
0.096.
And then 0.096. So like 1/10 of a pound. And if you've got something that's really tiny, right, we can multiply this by 16 to get ounces. So
1.536 ounces.
say that one more time, please.
1.536.
536 ounces of nitrogen. So that seems a little more manageable. 1.5 ounces of nitrogen seems a lot more manageable than 3 pounds. All right, and then we're going to just do the same thing for our phosphorus and our potassium. So we have 5 pounds of phosphorus multiplied by this. And then same with our 2 here. All right, and 5 times 0.032.
0.16.
All right, and then we're going to multiply that by 16. And that's going to give us 2.56 ounces of phosphorus. And then finally for our potassium.
That's a 0.064. And 1.024 ounces.
All right. How are we feeling about this math and what just happened here? This is something if you're a little concerned or confused or don't feel comfortable speaking up now, please let Lilius and I know. We are happy to walk through this with you for your soil sample later on too. So know that.
Are you going to talk about how we get ounces? I mean, like,
Yeah.
what do we use to measure the ounces?
So this is, if you've got a scale, this would be a really great time to use a scale for that. And we are also going to go look to, right, because all of this is in terms of pounds or ounces is the weight measurement. So we would want to use a scale for that. I'm actually going to switch back over to our soil sample results page, because I think this might also help answer some of your questions.
And for those of you, I use a kitchen scale a lot in my kitchen when I'm doing things, and I have one that does it in grams. And if it's even easier to go to grams on this, because you've got some percentages of ounces, you can multiply those ounces by 28.35, and that will get you to grams, if that's helpful.
So what if we don't have a scale?
Well, I think that's what Bethany's going to share now, is how you
Yeah.
can use this information to do some approximation if you don't have that.
Okay.
Right.
And Bethany, I went ahead and this slide, if you go to the next slide, I made the bottom part bigger so folks can read that too. Maybe? Oh, you know what? Hold on. Maybe I have to save it.
So while Lilius is, thank you for doing that, pulling up a zoomed in version, if you go back to your soil sample results, you'll notice at the bottom half, there's a whole bunch of text that says comments. And this is a technical jargony term, right? This is kind of science jargon to tell you all of these things. But what we really want to focus on is at the bottom, which is the ratios of NPK. So you'll see kind of these difference to be used in pre-mixed fertilizers. So based on your specific soil sample recommendations up top, the soil lab has said, okay, we know that you don't have a scale at home and you're going to go purchase a fertilizer. And fertilizers come in these different kind of numeric ratios of NPK. So you'll see like 10, 10, 10 is a really common one. 19, 19, 19, 2, 4, 6. So 2 parts nitrogen to 4 parts phosphorus to 6 parts potassium are all there. Let's see if I can.
It should be there now. Oh, why is it not updating? Sorry.
Okay. Oh, here it is. Found it.
Oh, cool. Okay.
Cool. All right. So you'll notice on all these different ratios here. So this is if you purchase a fertilizer, you'll then utilize the same thing of pounds to apply per 1,000 square feet. So for the soil sample that we just looked at, if I wanted to apply, for example, a 10-10-10 fertilizer, I would need to apply 20 pounds per 1,000 square feet. But as we talked about, I only have 32 square feet. So I'm going to use that same calculation ratio to multiply that 20 pounds by the 0.032 to figure out how many pounds of that item I would need. And Karen, this is a point too, where if you have sometimes on your specific fertilizer bag, they may have an equivalency in cups for their specific item. Because fertilizers come in a lot of different forms, right? So powdered, granular, liquid. So I can't tell you specifically, right? Oh, it'll work always this way. We are working in pounds, which is a weight measure on this. So we're converting pounds to ounces if we have something really small. However, if you're buying a product, on your specific product, it may tell you, 1 pound is equivalent to, for example, this, right? It says 7 pints equals 4 pounds. And this is to add a powdered sulfur up here. So you may see something similar if you're purchasing a fertilizer, where it'll say, X number of cups or pints is equal to a pound. And so if you happen to have a measuring cup, you can kind of figure that out. All right, so from here we want to think about, so we figured out what we need in our soil, the different amendments, and we want to go out and we know we need to add some different nutrients to our soil. So fertilizer is a substance that increases the nutrient quantity of your soil immediately. So fertilizers are designed to provide kind of an immediate food source for your plants. So fertilizers do not change the texture of your soil. They do not increase the organic matter of your soil at all. They are strictly providing food immediately. There's lots of different types of fertilizers out there. And so you need to pick the one that fits your budget and your values as a gardener. If you are very interested in being an organic gardener, you want to look for the OMRI, the Organic Materials Review Board label on your specific fertilizer. And that will tell you that it is approved for organic gardening. Does it do anything different ultimately than some of those? No, right? All of these fertilizers are providing nutrients for your plants. But that's just a personal choice that you will have to make as a consumer. What you do want to look at on all of your fertilizers is kind of this kind of nutrient panel on the side. So this 15, 15, 14, right, should match something that we saw back on our nutrient recommendation spreadsheet. So if you're going to buy something, take your soil sample results in with you to the store. Even if the folks at the store can't help you, you can kind of match these numbers over here to a number on a product to help you figure out, is this something that I should add to my soil, and in what kind of quantity?
So this one is not a good choice.
This specific one that's up here?
Yeah.
So let's go back and look. So this one is a 15, 15, 14. So let's look and see over here if I've got something similar that's listed. And you're right, it's not, right? That ratio is not really recommended for this garden. So I would kind of keep shopping around.
So how many columns do we look at? I see the 3400.
Yeah, so the columns that say NPK at the top, these have all the different, so it kind of reads left to right. So NPK, so if you were to buy a 34-0, you would apply 6 pounds.
Yeah. And then another choice is 200.
200.
Okay.
So
Yeah, that's showing the actual nutrient that you would get from applying that 6 pounds.
Oh, I see. Okay.
Mhm.
So you're actually looking at just that first column.
So you're looking at this column, and then it happens again over here.
Oh, I see.
So
Okay.
it happens twice, right? So the second where it says fertilizer analysis.
Yeah. All right.
Yep. And then pounds to apply.
Okay.
And then over here is like how much of this will actually be available to your plants.
Okay.
Good questions.
And if you're if you want to have kind of a backup to make sure that you're getting the right fertilizer for your garden, you can always bring this with you when you go to the garden store and show it to a staff person and have them help you navigate like which fertilizer would be the best. They should have that knowledge and be able to help you navigate that.
Absolutely. And I just also want to stress too, if your soil sample result says you only need one thing, it is possible to purchase just that one item too. So if you've got something where you only need nitrogen and potassium, it's very hard sometimes to find those paired together in a fertilizer, but you can buy each of these separately too as an additive as well.
Yeah, and that's where that handout that you all have that has a lot of different fertilizers and amendments listed in it can be really helpful because it will tell you what the name of the product is and which nutrient it's going to provide to your garden. And a lot of the things listed in that are individual nutrient, provide an individual nutrient instead of a combination.
For sure. Any questions about soil nutrients, nutrient calculations, and fertilizers?
Well, I'm still not sure how I'm going to get 1.5 ounces if I don't have a scale.
So that would be once you purchase your product, if you're going to be purchasing a fertilizer, look and see on the back if it's got kind of a conversion of cups to pounds,
Okay.
and kind of go for and use that to help you to figure that out, moving down to ounces. And we can certainly help you with that later on too, once you've got your specific product. It's hard to give you some specific guidance without knowing exactly what you're applying, because fertilizers, particularly if they're mixed, come in different forms, right? You can buy a liquid, you can buy a granular, you can buy a powder, and so that'll change, right?
Let's go back to that bottom chart on the soil. Yeah.
This one?
Let's say I get 10, 10, 10, 10.
Okay.
And I'm supposed to apply 20 pounds.
Right.
Or 20 pounds to 1,000 square
20
feet.
pounds to 1,000 square feet. So what you need to do now is figure out.
So I multiply that times 0.032.
Right. Or
Yeah,
whatever your area is. Mm-hmm.
Okay.
Right.
So, and then I multiply that times 16 to get the ounces.
Correct.
So
And
I get something like 0.64 or 64.
So 0.64 is, you would need 0.64 pounds of 10, 10, 10. So a little more than half a pound of 10, 10, 10 in my 32 square foot garden.
Okay, so then I multiply that times 16 to get the ounces.
Correct.
Okay, so now I have 10 ounces.
Correct.
yeah.
So how am I going to get the 10 ounces if I don't have a scale?
So again, on your, so if you'll look, so up here on our soils, it says 7 pints equals 4 pounds for powdered sulfur. Okay. So on your fertilizer bag on your bag of 10, 10, 10,
Yeah.
it may say 1 cup measuring cup equals 1 pound.
Will a bag always say that?
Many of them do. And so as a consumer, if this is your concern, I would purchase one that does say that.
Okay.
You don't have a scale, but you have measuring cups.
Okay. So let's say it does say 7 pints equals 4 pounds. Mm-hmm. Okay, so now how am I going to get the 10 ounces out of that?
Well, usually it will say what Bethany said, where it's like a cup equals 1 pound. Usually it's not as complicated as 7 pints equals 4 pounds on a bag.
Yeah.
And so if you need 10 ounces and 1 cup equals a pound of 16 ounces, then you would need to divide 10 by, let me think about this. You're going to really push.
Normally a cup is 16 ounces, but that's like fluid. I think that's like fluid.
Well, a pound is 16 ounces.
Yeah.
So if they're saying a cup is a pound and weight, right? We're talking about weight. then you've calculated that you need 10.24 ounces in weight.
Yes.
And so the ratio is 10 divided by 16, right? Let me just do that. Yeah, so you're going to need about 0.64 of a cup. So a little less than 3/4 of a cup.
Yeah, all right.
Don't you need to use that conversion of like that 7 pints equals 4 pounds or whatever that conversion is, though. You're not, that number is getting left out of that whole equation. Sorry.
Well, that's only if you're talking about powdered sulfur, right?
Okay.
What Bethany was giving was an example that powdered sulfur, 7 pints equals 4 pounds. But a lot of times on a bag of fertilizer, that's a small, like we're talking about small quantities usually. If you're talking about big quantities, that's going to be different.
So if I
But
bought
on
like,
a lot of these, yeah, like that garden tone that Bethany is
right
showing,
here.
it will say something, it usually gives like a smaller ratio. So it will say something like 1 cup equals 1 pound. And I'm not saying that's what it's going to be, but it will be a smaller ratio.
So
So
is that,
then you would,
is that
Mostly
on
just that ratio needs to be in there is what I was saying. Sorry.
Yeah.
yeah. So actually, if you go back to that, then if your recommendation is 10 ounces in weight, and it's saying that that 1 cup equals 16 ounces in weight, then you're going to divide 10 by 16, and that's going to give you how much of a cup you need.
Okay, so
Does
does
that make sense?
yeah, does this bag right here of fertilizer 15, 15, 14, does it say anything about that equivalent?
This is a zoom in of just the nutrient panel. I did not take a picture of the whole side of that, and that is my mistake. But it will often, so just pretend like you're reading a cereal,
Yeah.
you know, like a bag, like the label, you know, the nutrient facts on the cereal. It'll tell you right up at the top, a serving size of, you know, Cheerios is,
Okay,
you know,
all
as
right.
a cup. And so then it'll say something similar at the top, like, you know, 1 cup of this product is equivalent to, you know, will cover you know, is equivalent to 1 pound or something.
Okay.
And if you don't have that information, and this might, I'm going to try to say this clearly. Sorry if it gets confusing. If you don't have that information on your package, you will know as that full package how much that package weighs. And you could measure out how many cups are in that package to find out, okay, if my package weighs 2 pounds and there are 8 cups in that package, then I know that that 1 cup is 1/4 of a pound. Does that make sense?
Yeah.
Okay, cool. Y'all are really testing my math brain this morning.
I know, early morning math. You know, and if you like, if this is still confusing, or if you end up purchasing something and you're like, I don't know what to do, please contact Lilius and I, and we are happy to help you figure it out. It is a lot easier to do this with known numbers than trying to like guess based on an unknown. So we are happy to help you walk through that as well. So just throwing that out there. We're not going to go away after today. We're going to still be available.
Yeah, and we share this information because not only because it's really helpful to understand as a gardener in order to have healthy, thriving plants, it's also we really want to make sure that folks know how much fertilizer to apply so they're not over fertilizing or under fertilizing. And so, you know, please reach out because we know that this can be confusing, and it's not super simplified. There's not a standard, you know, kind of across all where you can get this information easily. So really don't hesitate to ask us for more help. There were a couple questions in the chat that I wanted to go back to real quick.
Absolutely.
Marlene was asking, should you not use a slow release fertilizer in a garden? I think we're going to talk about that a little bit, right, Bethany?
Yeah, you're going to talk about that a lot with composting. So
yeah. And just just were you gonna, I can't remember if you've already talked about conventional versus organic.
I guess in the briefest sense of you know, that they both exist, not so much as the what that means. So I'm happy to touch on that a little more.
Okay.
So if you are purchasing a fertilizer, and in addition to knowing that you want it to be organic, right? The first thing you're going to do is look for this Organic Materials Review Board symbol, which is down in the corner here. The tricky thing about the Organic Materials Review symbol is that it is not promised to be on every organic package. So if you're really serious about buying organic, omri.org, and you can type in the product name of what you're looking at, and it will tell you if it's organic if it's on the is a certified organic product or not. More and more companies are putting the OMRI label right on their bag, which is awesome, and it makes it way easier for everyone, but they don't have to. So if you're really committed to that, check that out. What organic means in this sense when we're talking about organic versus non-organic fertilizers. Organic fertilizers organic fertilizers are made from naturally occurring sources. So a lot of organic fertilizers that are nitrogen based will be made from dehydrated chicken manure, for example. You will see cottonseed meal as another really common nitrogen based fertilizer. Ground up kelp from the oceans is another one, right? So you kind of see this pattern of things. And just like when we're reading the side of our cereal box, it'll tell you on there what your specific nutrient is derived from. And so if you're buying something that is not certified organic, it may say that it's derived from, so on this label, right, polymer coated, sulfur coated urea. That does, right, urea does exist naturally, but there's a lot of things that have happened to it in between. So it's more of a synthetic or lab-based derivative of that formula. Again, there's nothing wrong with using organic or a synthetic-based fertilizer. They're both doing the same things for your plants in terms of making the nutrients kind of readily available. It's really a kind of a personal choice on what you want to do with your garden and how you're feeling about all of those things. Is one of them safer or not? The answer is don't eat either of them. They are not meant for human consumption. Don't eat them. Don't feel safer about ingesting them in general as well. So there's nothing wrong with either of them. This is a personal choice that you need to make on both of those. And, you know, we're happy to answer questions too about all of those different things as we kind of go along, or if you have questions later. Does anyone have questions now about kind of these two big categories of fertilizers?
Linda had a question about using gypsum to replace sulfur. And Linda, if you look at that handout, the soil amendments and fertilizers handout you all have, there's a description in there about gypsum. It does have sulfur, it does contain sulfur, but it also contains calcium and a good amount of calcium. So it just depends on what, you know, if you don't need more calcium in your soil, then you might consider, you know, using sulfur versus gypsum that has both. If that makes sense.
Mm-hmm.
All right.
Talk about lead.
Let's talk about lead.
Talk about lead. All right. Continuing on with our math and numbers theme, several folks in this class did lead samples as a part of their soil sample result. So lead is a naturally occurring element in all soils. It occurs naturally in pretty low levels, so between 50 to 40 parts per million of lead. What that means is that for every kilogram or 2.2 pounds of soil that we have in a natural environment, 15 to 40 milligrams, so just a little bit of that weight, will be dedicated to the element lead. It's natural, it's there, and in small amounts, that's normal. However, we as humans spend a lot of time altering our environment, and human disturbance to soils and the surrounding environments can frequently change and elevate levels of lead in our soil. So some things that we think about pretty often that we're probably aware of is maybe like lead paints. So if you have an older home that may have been painted with lead paint at one point in time, any paint that is flaked off your home can live in the soil. Lead does not break down very rapidly, which is why the levels of lead in soil can elevate pretty rapidly and stay high. However, lead doesn't move around a whole lot. It doesn't bind to other things very often. So you can have really high lead levels in one area of your yard and maybe 3 feet away have very low lead levels. So it can be hazardous. It can be present in really high amounts, but in very specific spaces. And a lot of the reasons that it is elevated is because of human disturbance. So in our urban environments, and what we see a lot of is kind of the older homes in Louisville were painted with lead. That lead paint has fallen off our houses and is just hanging out in that kind of space right along the edge of our house. We also had leaded soils here in the US for a long time. So if you have a long-standing garage or live next to a roadway with a lot of traffic, lead from soils can end up in lead from car fuel can end up in soils close to roadways. And also if you've ever seen folks who have maybe changed or had older gas tanks around the soil around that will often have elevated lead levels because of that too. So the biggest risk to humans with lead in soil is when people directly ingest that soil. So like I said, lead does not bind to other things very often, and plants do not take it up very readily because it doesn't do anything for them in terms of nutrients. It doesn't stick to anything else that the plant might eat. So lead just hangs out kind of by itself as little tiny particles in the soil. And for us as humans, our biggest risk is ingesting that soil. So we're all thinking, well, no one goes out, right, and takes spoonfuls of dirt and puts it in their mouth. But what happens is if we're gardening, we can kick up some dust when we're moving things around, and we inhale those tiny lead particles. Those tiny lead particles can also get stuck on the exterior surface of root vegetables and leafy plants that are low to the ground. And then we can ingest them just by eating those different plants. So again, our biggest risk for lead with lead contamination in soils is from direct ingestion of that contaminated soil.
Erin made a really good point that kids totally eat dirt.
Kids do totally eat dirt, right? And that, right, very, very, very good point. You know, like watch your kids. Try to keep them from eating soil and eating dirt. So the University of Massachusetts is the facility that all of your soil tests went to. And they use a different reporting method than that milligrams per kilogram that we looked at. They use something called the modified Morgan method. And what that does is it measures extractable lead. So lead that can be removed from the soil, like the lead that could impact us as people, which is a fraction of the total amount of lead. However, they've created a little ratio that they can utilize to estimate the total soil lead levels. So when you all look at your soil test, what we are gonna look at, where'd my little pointer go? is we're going to be looking at this number that says extracted lead is what is going to be reported. And so for this test, anything that is less than 22 is considered a low lead level in the modified Morgan scale, which is the equivalency of being less than 299 parts per million of lead in soil, which is the EPA level that is considered low and acceptable, so not to worry about. And then it kind of goes up from there. So a medium level of lead in our soil is in the modified Morgan method that'll be reported in UMass, is 22 to 126. High is 127 to 293. Very high is greater than 293. And then you can see those equivalencies in total lead all the way on the right. Questions? All right, so here we have a zoom in of the results of University of Massachusetts lead test results. So you'll notice, right, that they also report in this results the soil nutrients, right? So we have our soil pH, we have our macronutrients, phosphorus, potassium, and all of that. And then their values, the micronutrients, and then at the very bottom, we have lead. So if you've got a soil lead test, I want you to try to find that on the bottom, and then you're going to look for this value found. Boop, boop, boop. There we go. So if your value found, right, 5.2, and then the optimal range, right, low lead levels are anything less than the 22. So if the number that is related to your specific lead test results is less than 22, you have low lead levels. So, right, so here it is again, kind of all together. So lead levels that are low, less than 22, so this is considered a safe level of lead in your soil, right? How are we all doing? So if you are having kind of looking at lead levels of your soil at any level, these are just some general practices to think about to reduce your lead exposure if you're planning to garden. And then at any level. So first is to locate your garden away from buildings with old paint or heavily traveled roads. And this is something, right, we've talked about in our very first class when we were talking about siting your garden. So if you're still kind of on the fence about a couple places and you know your home or maybe a shed in your yard or area is older, maybe try to move a couple feet away from that building to decrease your lead levels. If you know you have lead in your soil, focus on planting fruiting crops. So things where we're not eating the leaves or the roots. So tomatoes, zucchini, green beans, peas, broccoli, whole lot of things there. You can also build your soil mass and ultimately, right, dilute the lead presence in your soil by adding a lot of organic material and compost, which Aurelius is going to talk about next. Come back to that soil pH again. So we talked about that optimal soil pH. So lead is less available in soils when we have a pH of 6.5 to 7. So really dialing in your soil pH can be a really important way to help reduce the lead availability in your soil. Wash your hands, wash your kids' hands, wash anything that is coming out of the soil before eating it or before eating. Wash it very, very thoroughly. If you're using root vegetables and you're concerned, peel them. Taking off, right, again, our biggest concern here is our actual ingestion of the soil. So if you're peeling off like the outer skin of a carrot or a potato, any soil that might be left after you washed it will be removed by physically peeling the skin away. If you're harvesting leafy greens like lettuce or spinach, the leaves that are lowest to the ground, I would just go ahead and discard those, put them in your compost rather than cleaning them and then being worried about them. Finally, covering your soil to reduce dust in your garden is a really great way to keep us from accidentally inhaling any lead particles that may be in our soil. We've all experienced dry soil that gets blown around. So by covering it with mulch or some other material, you just eliminate that soil from moving around. In our soil sample results sheet online, there is a specific handout in there called How to Read Your Lead Test Results. Please, if you did a lead test, please review that afterwards, and then also check back with Lilius and I if you have questions. And so these are the specific recommendations from that sample based on the different levels of lead that are found in your soil. So if you have low levels of lead, following the good garden recommendations that we just went over is enough for you to continue to garden safely with levels of lead that are 22 or less using the modified Morgan method. If you have medium levels of lead in your soil, follow those good gardening practices, but also keep your kids out of the soil and keep your soil covered as much as possible. Try to grow a raised bed or something where you're not growing directly in any contaminated soil, and fill that raised bed with clean soil. If you plan to grow in the ground, don't grow leafy vegetables or root crops in that soil. So if you have high levels of lead in your soil, go towards container gardening. We get to a point where it is not safe or advised to grow in soil that has high levels of lead. If you know that your soil has high levels of lead, keep it covered. This is a great place to have a perennial ground cover or a lawn, which reduces our dust and keeps things from kicking up. It also keeps our kids from digging in it quite as much. Build a raised bed and then put a liner. So actually create a physical barrier between the in-ground contaminated soil and then the soil that you're planning to grow in your raised bed. And then very high, contact the health department, Cooperative Extension, or our local EPA office for recommendations on what to do there. Questions about lead in soils in general? If you have questions about your specific soil results, we can talk about them here. If you want to talk about them kind of at the end of our class time together, or privately afterwards, we are happy to do that too. Questions?
I just wanted to share regarding lead in soils that when you are thinking about Bethany shared some good examples of where you might find lead contamination. And if you are testing for it, lead, when we see high concentrations of lead in soils, it's very, it's not dispersed throughout, like it wouldn't be dispersed throughout the whole yard. Usually if you're getting lead paint flakes off the house, it's going to be right next to the house. So when you are testing, when you're taking samples in areas where you think you might have contamination, you really want to focus that sample in that area directly. It's a little bit different than when we did sampling for our gardens and we looked at a big garden space and we took different samples and mixed them together. This would be something where you would really want to take the sample directly from the area where you think that the contamination is and then test that specific area. Just to share an example, there was a gardener in a neighborhood in Louisville where they have a backyard garden, and took a couple different samples throughout the yard, and took one really close to an old garage, and found really high levels of lead right next to the garage, but in the rest of the garden. So when this person found those high levels right next to the garage, we went back and tested in like 5-foot increments from that garage through the rest of the garden. And as soon as we got, a couple feet from that garage, the lead levels weren't there in the rest of the garden. It's totally safe to garden in the rest of that space. But then looking at this recommendation, you would stick to, this person had found levels in that high range. And so this person now, in that area right next to the garage is where they used to have their compost. They moved that and are capping that soil, basically covering it, and so won't be disturbing it or using it in any way, but they're totally okay to garden in the rest of the space because the lead is very concentrated in that one area. So I hope that makes sense. It's not, if you find that you have some concerning levels of lead, please come to Bethany or I, and we can talk you through how to determine if it's just concentrated in one area, or if you've got it throughout, the space, and how to manage that. Because it is very possible to use the other space if the lead is only concentrated in one area. And that's generally what happens.
Any questions about that at this time?
Okay, let's switch over to talking about compost. So I'm going to just talk through some methods on how you all can create a nutrient dense amendment for your soil that will also condition your soil, and you can do it for free, just from waste that you got from your kitchen and also from your garden itself. So we'll just go through kind of how to set up a compost pile, some different methods, some different kind of composting systems that you can use, and how to troubleshoot some issues that you might have. Compost is a fantastic resource for nutrients in your garden, and it's going to give you a lot of those different nutrients that we've talked about today. It's also full of microbial activity, and is just going to have a lot of those microbes that we need in the soil, and fungi. And so it's a great resource for that if you feel like you have a soil that might, be lacking in that life. It's great to add. It's going to fall in the category of being an organic amendment. So it will break down slowly over time in your soil, instead of being something that you would put on if you have like an immediate issue and you needed it to release really quickly. But over time, it's going to provide a lot of great nutrients to the soil. Generally, when we are thinking about composting, the ingredients are pretty simple to kind of put into two different categories. We have what we think of as our greens category, which is going to be our nitrogen-rich ingredients. And then we have our browns category, which is going to be our carbon-rich ingredients. So when you're trying to figure out, kind of what is what, I find it a little bit helpful to think about things that are kind of like in our minds alive in a sense, and things that have aged or are dead, right? So in our greens category, we have all of our fresh vegetable and fruit scraps and grass clippings that are fresh, leaves that are fresh, and animal manures and coffee grounds. And then in our browns category, you've got wood chips and shavings and paper, newspaper, cardboard, paper towels, things like that, straw, hay, and then some bread, rice, pasta, and eggshells. So those are kind of examples of what you would have in each category. The ideal ratio that you're using in your compost is going to be 1 part greens to 2 parts brown. and we'll talk a little bit more about like how you build that up. But things that are good to keep out of compost at a home composting system are going to be animal manure for many omnivores. So don't put your cat poo or your dog poo in your compost. There are pathogens in that manure that are not broken down easily in a home composting system. And so we want to keep those things out of our compost. Things like meat and bones, dairy, grease, oil, fats, fish and seafood, all can be something that can be composted, but are better to be composted at an industrial level because they can attract pests that we might not want in our compost system. And then I would recommend leaving diseased plants and weed seeds out of your compost because again, our home composting systems don't generally get hot enough to kill the diseases and the weed seeds. And so if you can, put those in your yard waste, they get sent off to a more industrial composting system and they can break them down in those systems. Here's some examples of different types of ways that you can compost. We'll talk a little bit more about these in depth, but you'll see, in the center, there's a very simple, T-post in the ground with wire cage wrapped around it type of system. And then on the left, those are the closed system tumblers. And then on the right, you've got some systems where you're using wood and you're building bins in order to do some composting. So this is just a general idea about how you can build your compost. You want to do it in layers. Every time I bring kitchen scraps out to my compost, and those are my greens, I throw in some straw or some paper, or maybe some dead leaves, and I'm building those layers because you want you need both layers to be interacting with each other in order to decompose the material. So you can see here how you could build layers with using different ingredients. You've got, wood chips as your brown there on the bottom, and then you've got some green leaves, then some brown leaves as the next brown layer, and then some green grass clippings, the straw as the next brown layer, and then you've got some kitchen scraps there in the middle, and then brown leaves on top. So this is a good visual of kind of thinking through how you can layer your compost. If you're using a bin system, which can be really helpful if you're doing a lot of composting, it allows you to be able to have a space where you can turn your compost. So composts need a couple different things in order to, compost systems need a couple different things in order to start that decomposition process. They need to have air in them. They need to have some moisture. They need this ratio of greens to browns and nitrogens and carbons. And so it is helpful to be able to turn the compost to allow some air to enter that system. And if you want to create compost quicker, the more you turn it, the faster things will break down. So using a bin system can allow you to set up your compost pile in that first bin. And then once it gets full, you can actually turn that pile into the second bin by, the idea is that you're taking everything that's sitting on top or the edges and kind of getting it into the center. So it can also be breaking down. So now your second bin is going to sit and you can start refilling that first bin. And then you can turn your second bin into your third bin and let it finish. And then kind of continue the process of now first goes into second, and then I can start building my first again. Where in that third bin, now you've got your finished compost that you can use. So that can be a nice way to kind of move things through. It is, I think, is the next slide a picture of that plastic, the black one? Yeah, so when use these enclosed systems, you can, you're basically turning it within itself. So a tumbler, which you see on the right, is a fully enclosed system. with tumblers, you have to turn them every day in order for them to work. And they are great systems if you're worried about pests getting into your compost to use because it's fully enclosed. The system on the left is mostly enclosed. If you're worried about pests, you'll want to put a barrier on the bottom because the bin sits right on the ground. So you can use hardware cloth to keep any pests from burrowing underneath and getting into your compost system. And with that one, you're going to actually be going out there and physically turning it into itself and kind of just mixing that compost. And then once it's starting to finish, it's going to settle at the bottom. And so usually these systems have a little door or some way to access the bottom of the compost pile so that you can shovel out your compost that's ready to go.
Did I hear you? I'm sorry, I had a quick question. Did I hear you right that with these, because I have some that rotate, they're smaller. I'm kind of like outgrowing them, but did you say that you turn those every day? Or did I hear you wrong?
Yeah.
Every day? Okay.
With those tumblers, you really want to turn them every day if you can.
Okay.
In order to keep that decomposition process happening.
Okay.
Because they are closed, they need more air to be incorporated into them.
Right.
And Bethany made a point in our last class that these systems the tumblers can get heavy. So if you're looking for a closed system, it sounds like Susanna has a smaller one.
It's like 2 of them. It's like a double.
Okay.
They're decent size, but they're relatively. I've already started another one because we have so much compost.
Yeah, you got it. You got to do something with it, right?
Yeah.
So you can get them in different sizes, depending on, kind of just like what your capacity is to turn them and your strength and how confident you feel in that. But they can be great. Yeah.
I got it. It's fine. But yeah, I was just curious because we do turn it fairly often. I wasn't sure if I was turning it too often, but that answers it. I can turn it more if I want. Okay. Thank you.
Yeah.
Lilias, there was a question in the chat about your commercial accelerators as well as adding beer and maybe ammonia to compost to help it go faster. What are your thoughts?
I'm not familiar with that practice. And adding beer or ammonia to help it go faster. I know that there are hundreds of different ways to compost and tons of different methods that folks use in order to, to accomplish a different goal with your composting systems. There are methods where you can, put pipes into your composting system to get more air into them and other things. I would just say that if you, at a very simple level, if you're just getting started and want to get a composting system going, the basic concept is that you need the materials that are going to decompose, the organic material, and then moisture and air in order for it to work. And so by simply, if you want your composting system to work faster, then you can turn it more often and maintain that moisture level so that it's heating up faster and in order to just decompose faster. But you could probably go on YouTube and find like 100 different ways to compost. But at a simple level, this is kind of just getting started kind of way to do it.
Yeah, we had another question about what if I just dug a hole in my garden and dumped my kitchen scraps in there and covered it back up?
Yeah, that could work. You can, Bethany and I refer this as like lazy composting. You can absolutely be a lazy composter. You're basically, doing what's happening in the soil every day, and that's organic material being incorporated and getting broken down by digging a hole and putting things in it and covering it up. You can do that in your own bin, like in this black bin. If if you're just going to go out there and put in your kitchen scraps and throw some browns on there and just let it sit, it's just going to take longer for it to break down. if you haven't fully enclosed that system, it is possible that some little critters are going to come because you just created like an awesome little grocery store for them to come and feast. And so if you do find that you've got some critters that are poking around your composting, you just turn it. The more you're in there, the more you're moving that earth and those things and disturbing it, and there's humans around, like they're not going to want to be in that space. So if you are a lazy composter, maybe tumbling or a fully enclosed system is for you. If you're going to be more active in turning it, then you can use, you know, those very simple ones where you just have like a post and a wire cage, and you're turning it, you know, pretty often.
Yeah.
Definitely consider location when you are setting up a compost. Ideally, you want to have it somewhere where you can easily get to on a daily basis, right? Because you're going to be producing, if you're doing a lot of cooking at home, you are producing kitchen scraps every day. And I'm assuming you don't want those sitting in your kitchen getting stinky. So having it somewhere close is going to mean that you're going to get out there, you're going to empty your compost bin. It is a good idea, you know, just to have it in a space that is easily accessed, because again, you're going to want to turn your compost, you're going to want to harvest from it. So having it be in a space that you can get to and you can move around is a great idea. And just give yourself, you know, a lot of space, you know, to be able to do that. And then it's great to have it close to your garden so that you can, you know, take that finished compost and actually put it to use. This is what ideally your compost will look like when it's finished. You want to smell it, and it should smell like soil. If it's stinky, like a little bit of rotten food, then it's not finished yet. So you want to put it back in and give it a little bit more time. If you see big chunks of things still in there, then you know that it can keep going for a little bit longer. Sometimes I compost a lot of eggshells, and so eggshells typically take a lot longer to break down than some of the other ingredients that I'm putting in my compost. So what I'll do is I'll actually, if I smelled it, it smells really good, I know that everything else is broken down, but maybe there's just some big eggshells in there, then I'll actually run it through like a sifter or screen that I've made out of hardware cloth. And I can sift out the finished compost, and then I can put the eggshells back in to kind of keep breaking down. Sometimes that can happen with coffee grounds too. If you put a lot of coffee grounds in your compost, the coffee grounds take a long time to break down. So sometimes you need to kind of reincorporate them back into the compost. But ideally, you're coming out with this rich, black, beautiful compost, and something that you can put in your garden right away, or you can put it in some containers and store it, you know, if you're using it over the course of the year to amend your soil.
We had a question about worms, and would adding worms specifically to a compost pile help break it down faster, and maybe would they do all the turning for you?
So there are methods of using worms specifically for composting. It's called vermiculture. And red wigglers are the worms that are kind of our best at doing that work. It's absolutely, worms can be helpful in a compost pile. So if you feel like you want to throw some worms in there, go ahead. You're going to get a lot of worm castings, which are even more nutrient dense and incredible for your garden. Usually worms will find your compost. So a lot of times if you get it started out there in a, you know, you go back in a year, like there will be worms around. But worms are great composters. And if you don't have space outside to do a compost setup, having a little worm bin in your kitchen is a great way to create worm castings and to break down those kitchen scraps. And if you want more information about that, both Bethany and I have set up worm bins using like Rubbermaid tubs. It's pretty simple, so we could help you sort through that process. But you can also purchase worm bins, and there's lots of DIY videos on how to make them on YouTube too. I have a nephew, and who did that as his COVID project. So I had some fun video chats with him about building worm bins in Texas. It was an exciting year. And then lastly, just some ideas about where you can use your compost. I mentioned putting it in your garden. You can, if you don't have any plants growing, you're getting ready to plant, you can mix it into the first couple inches of your garden soil. If you already have plants and it's maybe midsummer and there's signs that your plants need a little boost, you can side dress your plants by sprinkling compost on the soil right around the roots of the plants and watering them to kind of water it in. And then you can also use it in your seed planting mix or your seed starting mix to add some fertility for those little babies to get going. So a lot of different ways that you can use. And then, oh yeah, and I just forgot about putting it directly in the planting hole too. If there's something that you're planting, like tomatoes, every year when I plant tomatoes, I put a little compost in that hole because I know tomatoes need a little bit extra. They're heavy feeders. So I'll put a little bit of compost in there to help them have some nutrients that break down slowly over the course of the season. And so that can be a great use for it too. Any questions about, any other questions about composting? Anybody have a system that, you know, they like and they use that they want to share?
We had a question generally about getting soil and compost. And there is a resource list, I think from week 1 of all the different companies that Lilius and I are aware of in Louisville and Southern Indiana that sell compost, as well as just garden soil as well in bulk, if that's kind of the volume you're looking for. And then obviously like any garden center will sell it by the bag. And then Marlena had a question about compost tea. How do you make it? What is
Compost tea. Compost tea is awesome. Compost tea is just a liquid version of compost, and you can make it very easily by taking a 5-gallon bucket and filling it with water and adding a couple cups of your finished compost to it. For 2 days, you want it to sit in there and you want to stir it like every couple hours because you do want to get some air incorporated into it. And then you can strain it through, you know, like a cheesecloth and use it to water. It's really good for watering seedlings. And you can use that. You can also use it instead of kind of that side dressing that I mentioned of putting compost on the soil surface and then watering it in. You can make compost tea and just water your plants with that to give them a little boost throughout the growing season. So. Easy to make and a really great resource for keeping, you know, giving your plants some extra boost throughout the growing season. You can also use compost tea as a foliar spray on plants. And that's kind of like a deeper, longer discussion, but it can be used once you've strained it, you can put it into a sprayer and spray it on the leaves of the plants as another way for them to get some nutrients.
Yeah. Another composting question, which is how long do you let the compost tea set out and stir it before you use it?
So you want to let it sit for about 2 days and you want to stir it about every, you know, couple hours. When I've made compost tea before, I'll stir it kind of morning, noon, and night, and then, you know, the next day the same, and then strain it out. If you leave it sit too long, then you can kill a lot of the microbial, you know, life in the compost. So you want to incorporate the air so they can live, and you want to strain it, you know, after 2 days and or a couple days. so that it's still in there once you drain out the compost.
Yeah. All right. So today, if you guys have questions, keep asking them. But today is our last day together. So we wanted to wrap up by finding a little bit about what you all learned over the course of our 5 weeks together. In the chat is the link to our very short post test. It will look very, very familiar. Hopefully you all completed this at the beginning too. It'll take a couple minutes if you don't mind clicking on the link and just filling it out right now. And just letting us know how you did, and keep having some questions about composting or anything else that we have learned.
Thank you all for being a part of this class. I hope over this past 5 weeks, we've provided you with the tools that you need to either get your first garden going or improve the garden that you've had, some tools that you can use kind of in your toolkit to assess issues that you might have in your garden space, and a little bit of a deeper understanding around how you can better understand your soil texture and soil nutrients in order to kind of, just have the happiest, healthiest plants you can have, and also be able to do a little bit of troubleshooting if you've got some issues. All of the classes that we've had over the past 5 weeks are available in the class folders, and then also on YouTube, on Jefferson County Extension's YouTube, as well as the Jefferson County Soil and Water Conservation District. They will stay there anytime you want to reference them. If you're looking for additional workshops and just opportunities that are coming up throughout the year to keep learning and sharing, the Jefferson County Extension Facebook page is a great resource on future workshops, as well as the Conservation District's Facebook page. And then the Food in Neighborhoods Community Coalition, which is at foodinneighborhoods.org, has a calendar where we try to post those opportunities as well. We will send all of these links to you all in an email after this too, so don't feel like you have to, capture everything quickly. Bethany has a fantastic Instagram at Louisville Community Gardens. Bethany posts a ton of great resources on there and really fun videos that she's making with gardeners around town. So check that out. You can find those videos on the YouTube channel. There's also a Instagram for the county extension office, as well as the Instagram at Louisville Urban Ag, which is the Urban Agriculture Coalition. If you want to get involved with the Urban Agriculture Coalition, head on over to the foodinneighborhoods.org/grow website. We meet every fourth Thursday of the month, and also we'll have like a vegetable plant seedling drive coming up this spring. If you want to help out with that. Usually when the How-To Festival is happening, we do a lot of work with the How-To Festival at the library. Super fun. It's just a great network of folks that are interested in food and growing food throughout the city. And last but not least, the City Growers Chat Hour happens every week. We'll be gathering today at noon for that conversation. It's a very informal conversation. Sometimes we have specific topics that we discuss. Sometimes we just leave it open and folks can just bring up things they want to talk about. Feel free to join us at noon for those calls every week. Maybe by the time, this fall happens, we can actually meet in person for some of those, but currently we're just doing them online. So we really enjoyed having you all, and we hope that you continue to stay in touch. If you have anything that comes up, let us know. Don't feel, you can reach out anytime. Don't hesitate to contact us. Yeah, thank you for being a part of this Zoom garden class with us.